and welcome to TTF Tech Tip Friday. I'm your host, Kurt Staley, that plastics guy. In continuing with our theme of physical property characteristics, I want to talk to you briefly today about one that came up in a client conversation, and that being notched Izod impact. So what is it? Well, it is a test that's designed to measure how much of an impact a specimen bar of a given material can take before it breaks. But the notch is what's really important. That notch measures essentially, well, once the test specimen has a notch cut into it in a pre-described manner by the ASTM specification, how much impact that specimen bar can take essentially with damage done to it. So as you may or may not know, the exterior of wall stock on a plastic part, we would refer to it as the skin. That adds a tremendous amount of strength to the part. So if we cut a notch through that, we're removing some of the strength of the part from that skinned up layer of plastic. And we can get maybe, if you don't want to think of it as a more realistic aspect of how much impact a piece of plastic can take, it would be perhaps a more conservative or worst case scenario. So you have an ASTM test bar that's put into a machine specifically designed to administer a notched Izod impact test. The test bar is locked in, and it's locked in vertically. Now, when I say vertically, the option would be to put it in horizontally and hit it with a force pointing down, but that's Charpy impact. That's a different measurement that yields different numbers and can reflect different things. My personal belief, and I stand to be corrected on this, the notched Izod actually appears to be somewhat more, if not destructive, certainly has the potential to highlight the actual failure point of a material more. When you have a weight attached to a pendulum hitting the notched specimen bar, it could, in theory, knock the top half of the specimen bar clean off. It's pretty severe. So you can look at the notched Izod impact value. In empirical, it's measured in foot-pounds per inch. In metric, it would be joules, joules per meter, joules per centimeter. Please check on your data sheets. But you are measuring the force required to break a specimen bar with the prescribed instrument following an ASTM or an ISO if you're doing Charpy or using a metric unit of measurement, it's ISO. So I hope that sheds a little bit of light. I would encourage you to Google the notched Izod test specification. You will see pictures of what the rig looks like that does it. You'll see a weight on a pendulum, and you'll better understand what I'm referring to. But it's a key component, especially when you're dealing with things like automotive interior trim, specifically above the belt line, where in the event of a collision, you might have a head strike with an interior component in the plastic, and you want to be able to understand how much of an impact the plastic will take, and even more so, how much it will take before it breaks. And that's another level of impact to consider. So that's really all I want to say about notched Izod and Charpy. Look up the specifications and you get a much better idea of what those particular specifications are talking about. But it's key, and it describes how much energy a particular piece of plastic or material can absorb. And that's your tech tip for Friday. Have a great day, a great weekend, and I will talk to you next week. And yes, there will be another physical property characteristic that we discuss. Take care. Bye for now.